Hello, everyone. Good afternoon, if it's evening for you, and good morning, if it's still morning at your side. Thank you for joining us today. I'm Hussein Saloom. I'm the Executive Director of Energy Pro Electricals. Today, I'll be discussing with you about the power of hybrid solar solutions for the UAE market, specifically the commercial and industrial segment. So I'll be starting now and wait until more people can join in to discuss about our topic today. And hopefully that this will be an hour, and then we will have some Q&A feedback from your side and discuss in more detail. Initially, this is a disclaimer from our legal department on this presentation. As usual, this has to be shown in everyone. So these are presentations for educational purposes and not to be for any kind of professional judgment. So attendees should also note that these sessions are audio recorded already, and it can be published subject to earlier notice. So why we are discussing this topic today? Um, this topic is about hybrid solar solutions, where, in line with the UE policies to achieve the green agenda, we are offering this solar solutions in the commercial and industrial sector as part of cost-effective and renewable solution to meet these targets and guidelines. So these guidelines that has been set by the UAE leadership that by 2030 they look forward to have 50% of the clean and renewable energy sources supplying the UAE demand for 50% of that, and by 2030 as well to have Dubai at least having 25 of its energy sources from renewable energy sources like solar, basically solar, and for example in Ras Al Khaimah 20% by 2040. As an overall, UAE targets by 2050 to have 50% of its energy to be clean and green. So, in line with this UAE policies and trends, we look forward that these hybrid solar solutions are offering part of this policy and having the same insights and the same vision with the UAE leadership. So, in our today's topic, we will be discussing first about our company, its profile in the renewable energy field. Then we will go for the technical and commercial outlook about the solar hybrid solutions. Then we will show some design perspective for these systems. And finally, we will discuss about whether to own or lease the hybrid solutions, each case, what we should do and how we should approach it. So our company is called Energy Pro Electrical. This company is established in 2020 by a group of engineers and entrepreneurs that have been in the market for the last 20, 25 years with extensive experience in the power and electricity field. We are specialized in power quality audits. We are authorized distributor for many brands in the electrical products and the solar products. We are also specialized in innovative and sustainable solutions, including solar, battery energy system, EV charges, etc. We have a warehouse in Dubai in DIP for around 4,000 square feet, and we have authorization from Longi Solar, which is one of the top three brand leaders in the solar cells. Our organization is formed of four major departments in the sales, in the technical support, in the accounting, and the operational team. We have around 15 engineers and office support, back office support. We have around 50 skilled technicians and quality control. Our engineers are certified in different aspects, including solar, power quality, relay studies, and low voltage and medium voltage switchgear. We have advanced testing kits and power quality kits that can be used in on-site works and modifications and troubleshooting. Also, we have a very wide partners network that we rely on in our project execution, plus our warehouse. Our portfolio is divided into three major categories. First, our solution offering. We offer multiple solutions in the smart energy management, in the solar with the on-grid, off-grid, and the hybrid solution, which we will discuss today. We have also our solutions for the smart busways, especially for data centers. We have our harmonic suppression system that we use active harmonic filter for. We have also our power factor correction panels and solutions, EV charging stations, AC, DC up to 150 kilowatt. We also have battery energy storage systems that can be used as a backup for the solar or as general PV diesel systems. We also have our medium voltage switchgear and low voltage switchgear solutions like the medium voltage VFDs, etc. Our engineering relies on studies that we can do through ETAP softwares. We can do short circuit studies, relay coordination, load flow, harmonic analysis, earthing analysis, grounding studies, voltage drop, power quality, low voltage, and medium voltage. Also, we can do thermal imaging for LV and for solar panels. We can do also on-site works, whatever for engineering and solutions that we provide, like low and medium voltage maintenance and repair, solar installations and maintenance, site testing, retrofits, refurbishment, power upgrades, LV and MV. Also, we can do AHF installations, active harmonic filters, and commissioning, as well as VFD programming. I hope that everything is clear till now. If there is any comments or any notes, please write it to me on the LinkedIn. We'll be happy to address it on the spot. So, in relation to our solar products, we offer the solution and the product itself. We have a range of products. We have the PV modules. Basically, we have the latest technology of Longi, which is the HIMO X10, and this is a very advanced solar panel that can give up to 650 watt, and it has an efficiency of 24.5, and we can give up to 30 years warranty on that. Plus, we have the inverters, the hybrid, the on-grid, and the off-grid. Uh, we offer also combiner boxes, mounting structures, weather stations, control and automation, EV chargers, solar VFDs, solar street lighting, and battery energy storage systems. So these systems, we can either supply it loose or we can supply it as a full solution depending on the end user requirement. So our business model offering, we will uh, we can do different models. For first, we can be simple as authorized supplier for the PV product. Each product we can supply as an agent we have in the store, and we can supply it at a very good and competitive price. But our aim is not only to give that. Our aim is to provide the full technical support during pre-design stage, execution stage, and even after the sales support. And we have a big team that can handle this with the software required. Also, we can do finance referencing, especially that solar solutions require high finance or high capex and running opex. So we can also do finance referencing for these solutions, and we can offer some kind of support to handle the high investment. In addition to that, we can do the installation and the commissioning for all the system on, off, and hybrid solutions, and we can do the after sales operation and maintenance, especially that this system can run for up to 25 or 30 years. This is part of some of our achievements. We have executed around 5 megawatt of solar project till now. We have around 7 megawatt in the pipeline, and that's related to the solar products and projects. Um, we have dealt with key partners in the renewable energy in general, customers like DEWA, NAFCO, MDAD, Berkeley, and Dorar. And we have also dealt with prestige vendors and like Longi for the solar cells, Sangro for the inverters, Scami for the EV chargers, Dai for the hybrid inverters, Megawatt, True Light for the solar street lighting, Control Techniques for solar VFD, and Gem Battery for the battery energy storage systems. So to move forward to our core topic today, which is about hybrid solar solution. Hybrid solar solution is basically a solar solution that is mixed with several sources of power like grid or generator or battery storage. So it basically combines the solar power with these sources, a diesel or gas generator, and a battery storage system. Sometimes it's an optional. So this provides a very reliable power even when there is no sunlight, especially that during cloudy days or at night the sunlight will be absent. So we can have this kind of hybrid solution that gives a reliable and sustainable power. So the aim is to offer a continuous power supply and to reduce the fuel cost for sure and enhance the energy efficiency. In our market, we divide it into three major segments. One is the utility scale, and one is the residential, and one is the commercial and industrial. So our focus today is about the commercial and industrial segment, which relates to the buildings, the warehouses, the industrial buildings, the malls, the shopping malls, the uh, schools, hospitals, treatment plants, etc. While the utility and residential scale, we avoid for different reasons to tackle it for the time being. So basics of the designs they depend on three major power sources. We have the grid, we have the generator, we have the solar, and then we have the battery energy storage system. So the grid and the generator are considered as main sources of power. I'll explain in the next slides the reason. While the solar and the battery storage systems are not considered as main sources of power. For the solar, we consider it as energy saving source because it's not a 24-hour continuous source or not a stable source. Also, we'll explain it in the later slide. And for energy battery storage systems, we consider it as a backup source. So in our approach, we have these definitions in the first place to be able to look into the design and the mix of the hybrid solutions in the next ones. So if we go back to circuits 101, let's say, we have two types of sources. We have current sources and we have voltage sources. And without any of these sources, we are unable to form a grid or to form a power supply. So the voltage sources basically provide a consistent and fixed voltage output regardless of the current. And these are mainly generators and batteries. These are voltage sources and they maintain a stable voltage throughout the uh, supply of the load, whether it's 12 volt, 24 volt, 48, 230, etc. And it's very essential in stabilizing the output of the voltage. And without them, we are not able to form a grid or a power supply. On the other hand, the current sources are the sources that provide consistent current regardless of the voltage. And one of the major things here is that the solar panels are they work as a current source and they are not voltage sources. So that's why, due to the intensity of the light or the fluctuation of the sunlight, we consider it as a current source where the voltage varies. So these sources has to be integrated with voltage sources to be able to stabilize and convert the DC current of the solar panel into an AC voltage for the appliances. So it's very important in our approach in the design that we always have a voltage and a current source to form a power supply. And here we come to a second concept, which is the inverters of the solar panel. There's two types of the inverters. One is a grid tied and one is a grid forming. So the grid tied inverters are the current source inverters that we use sometimes, and it needs a grid voltage to be able to synchronize and feed the power of the grid. On the other hand, the grid forming inverters can operate as a voltage source to control the voltage, and these are sometimes used with the solar panels. But it requires a big size of PV panels to be able to have this grid forming inverters. So here we have to understand one thing, that our inverters can be either grid tied like a current source and or grid forming like voltage source. So this leads us to the next concept, which is the combinations of the hybrid solution. So in case there is a grid, we can have three combinations of a hybrid solution. The first combination is the grid with a PV and a battery backup system, where the grid works as a voltage source, or the battery with a PV as a current source. Or we can have the grid with a PV and a generator, or we can have the grid with a PV generator and the battery storage system, all the four supplies together. On the other hand, in case we have no grid, we can have a generator and a PV as a one solution, a PV and the battery storage as another solution, or all the three together. But it's very important to note that we cannot have only the PV as a standalone off-grid system without any voltage source, either a battery or a generator or a grid forming inverter. In the case of we have to have a grid forming inverter, it will need a high size of the PV, which will not be commercially viable. So these are the combinations that we have it on the conventional on-grid or the conventional off-grid. I will give one example of an on-grid hybrid solution, but then we will go to focus on the generator PV grid off-grid solution. This is an example of a grid-connected hybrid solution where we have supplied this to a DEWA application. It's an RTU application where we have the grid supply and we have added to it a PV source with a battery energy backup system. So this load was critical, means it have to have, in case of a failure of the grid, a backup support. And we installed this PV along with a battery as a backup. So if you see here that we have 8 panels of solar connected with a hybrid inverter to the battery storage system, and it's interlocked with the supply of the grid, and then it goes to the outgoing of the load. So the philosophy here works as the following. In case you have the grid going on, the solar cells will be charging the batteries during the daylight. And in case the grid goes as trips or goes off, it during the day it shifts to the solar panel. In case there was no solar light or there's no solar power, it shifts to the backup battery and takes the power from there, like the night mode. So this is a simple grid PV energy backup system for an in-grid solution. Now, the importance of this is that this could be used in far places or where the grid is expected to go off, or there's sometimes fluctuation in the grid, or it needs to be upgraded, but there's no room for upgrading the grid. So we add this in the on the system. This is an example of a on-grid hybrid solution. On the other hand, PV diesel systems, we use it normally in the off-grid solutions where we add the generator, and these can be made in different combinations. So this solution has emerged actually to face the challenges in the stable and cost-effective electrical requirements, because sometimes there's a distance and there's a high fuel cost, or sometimes we need to have a additional power on the system, or for the load we need to upgrade it, or sometimes there's simply not enough power, so we need to have this PV diesel generator option. So to discuss on the first one, and we discussed that the PV generator and grid, it's ideal for cost saving. But to discuss on the other hand, for the generator and the PV, it's suitable for remote locations, especially with a lower night time. So in case there is a lower night time, we prefer not to use any kind of battery storage. It will just add on the cost with no real use, and it focuses on minimizing the initial cost. However, in case we have a night load, it's recommended that we use a generator with the PV and battery energy storage system, because we can use the solar power to charge the batteries during the day and shift to the batteries operation during the night, saving on the generator diesel. Now we can also have a full hybrid solution, like we have the grid and the PV and the generator and the battery storage, but these will be special applications where there is a major load or a critical load that could be having, they don't want to have any kind of blackout, so we have to put all these redundancies in the system. So this is the four combinations of the PV diesel hybrid solutions. I will show the topology and the basic design concept that we follow in these systems. But before we do that, let me highlight some applications that we have been seeing in the UAE market, in the commercial and industrial, remote and inside city offices, where there is a small office requirement, 30 kilowatt, 40 kilowatt, 100 kilowatt. We can use these systems. In case there is temporary labor accommodation, where you need to use it for 2-3 years and then demolish it, where there's no grid power or there's a minimal grid power. Also, if there is some site equipment like cranes or pumps, you need to use it. Also, there's some special applications like sewage treatment plants, like telecom towers or drilling rigs or wellhead camps or temporary facilities, where you need this kind of PV generator requirement. This can be utilized and really have considered saving in the fuel consumption. So I'm present here a sample PV diesel design topology, where we have to do some basic consideration when we plan it. So I put this 4 snapshots of 4 times during the day and night, considering the following. Really, everyone knows that PV supplies in the day is around 5 hours, and UAE is a very ideal place for having this solar. But still, there will be possible fluctuation during cloudy days, or during some winter times, or few clouds passing, or whatever. So these fluctuations will be there. So we have to consider that the solar power is not a consistent and continuous power. The second criteria we have to consider in our design is the generator should always operate at a minimum of 30%. And this 30% is very important for the spinning curve, because in the case of fluctuations, the generator should be there ready to take the load from the solar. So that's why we have to keep it running at minimum 30%. Some generators could be 25%, but for the calculation now, we'll consider it as 30%, and it should not run more than 90% to avoid any kind of overheating. That's why we recommend to put as many generators as possible, either with smaller sizes, to keep that flexibility available. On the other hand, um, we have to design the uh, solar system not to exceed 60 to 70% of the maximum load capacity, because we have to keep that room for the generator to operate at 30%. So, taking this example, this is a 1 megawatt project, and we have designed it at 600 kilowatt solar cell or 800 kVA solar setup, and we have put three generators of 400 kilowatt. Uh, if we say, let's say at 2 p.m. or 2 a.m. in the morning or 2 a.m. in the midnight, the load is around 400 kilowatts. So there is no solar input. Then the two generators will run each at 200 kilowatt, which is around 50% of its capacity. Moving forward to, let's say, 10 a.m. in the morning, where the load is increased to 800 kilowatt, then we will have around 500 kilowatt of solar input, and the balance 300 kilowatt will be taken from the generator, each of around 150, because we need to take care that during this day solar energy, this could drop in a minute down to 100 kilowatts. So keeping two generators running, avoid loading one generator above its 90% capacity. But in case we don't have a lot of variability in the load, we can have one generator, but it's always preferable to have it multiple. Moving forward to, let's say, 3 p.m. or 2 p.m. in the afternoon, where we have around 850 kilowatt of load, we will have around 600 kilowatt of solar input, and the balance 125 kilowatt from the generators, two generators. So if you see here that the yellow shade is the saving we are having in the fuel consumption of the generators, and the blue shade is the consumption of the diesel throughout the load, throughout the day and the night. Moving forward to the rest of the day, let's say like 6 p.m., where we have around full capacity, then we have all the three generators running, and we have zero input uh, from the solar. So this is a typical day where you see the curve of the solar saving compared to the fuel consumption. This gives us an idea of the topology of how the PV diesel hybrid solution works. In this working, there are 5 or 6 concepts that are working together. In case there is a battery, there's 3 controls come into place. However, if there is no battery, these the first 3 concepts are put into place. So I just, okay, Harry, let me read. Harry is asking, what methodology do you recommend for sizing the battery energy storage system for a hybrid to balance the energy storage backup? Yes, I will come to this topic at one of the next slides after I finish just the PV diesel controller philosophy. Sure, I will explain about that. So the PV diesel controller topology depends on, without the battery, depends on 3 major controls that can be taken care by the powerhouse controller. The first one is the spinning reserve management, where the power, because of the PV power fluctuation, the controller of the generator ensures that it keeps up to 30% of the generator running. And the other one will be the generator loading management, which will control its working between 30 to 90% of its capacity. It does not allow it to go below 30%, and it does not allow it to go above 90%. And it controls the input from the solar power accordingly. And the third part is that it controls the reactive power management. So within, as all generators have a ideal performance between zero point 0.8 and 1 lagging. So in case it's below 0.8, it will start to lose. If it's above 1, it will start to act as a rotor, and also we will have losses. So the powerhouse controller will always try to control the power factor to be between 0.8 and 1. So these 3 philosophies are in control for the powerhouse management between the PV and the diesel generator. Now, in case we have a energy storage system, another 3 control philosophies come to place. One is energy shifting, means that the generator has to the generator and the PV try to optimize the use of the energy, the battery storage system. During the day, any extra PV solar energy will go to the battery and charge it, and during the night, any available energy storage, it will use it to save on the diesel. So this is called the energy shifting. Also, it will be used for ramping rate control in case there is any sudden fluctuation, any trip or a blackout from the generator or the PV. It will directly go to the battery and cover the load deficit. And also, in the case of battery energy storage system existence, we can have the generator off in case the loads are below 30%. And then it can shift to the battery and ensure that the load is supplied enough. So these are the six philosophies that the powerhouse controller take care in case of the PV diesel supply. So here we come to the question of Harry on the design criteria for on-grid hybrid or off-grid hybrid system, including the battery. So first, we have to know whether it's an on-grid or it's an off-grid system. So in the thing is, it's an on-grid system. We have first to look at the kilowatt hour, the energy consumption, not the power consumption, because the grid will cover the power. So we have to see what is the load profile during the day or the night, or if there's any different types of load during the day and during the night. So here we look at the kilowatt hour, and then we look at the space available for the PV, and then we see if there is any limitation from the utility on the percentage of the solar that need to be applied in the system, and that's in case of the on-grid. So, for example, if we have a 100 kilowatt a powerhouse, and we have the grid supply on it, so we need to see what's the space available. We calculate how many hours first the load is taking. Let's say 10 hours, 12 hours per day. So we multiply the 100 by the 12 hours per day. It will give you that kilowatt hour consumption. Based on that, we divide by the 5 hours, which is for the PV, and then we can get the PV sizing or the PV number of cells. Here we have to look at the space. If there's enough space, we can put the full. If there's not enough space, we have to check how much we can put, and the balance has to be covered from the grid. And here, it's very important that we take the approval in case, because if it's an on-grid system, we take the approval of the utility on the percentage of the PV that we have to put. And of course, here, generator will be designed based on the final criteria, how much we put PV and how much space available, and then we can size. Now, the generator is always flexible. In the case of the grid, it's up to you to decide how much you put based on the load profile. On the other side, the off-grid system have to take care first for the power, not the energy consumption. So because here you have no grid, so you need to take care of the load capacity, the maximum load capacity. And here you start with the kilowatt, not the kilowatt hour. So this is the main criteria in the design. First, for the generator, you have to have the generator covering the full size of the power, because it has to act as the voltage source, as we said before. And then you have to see, in case you need to put a battery system, how many hours you need to use that load and what's the profile. Is it a night load, a day load, or different percentage of the load coming in the day, different percentage going in the night? And based on that, you design your battery backup system. And finally, your PV system comes in line with the space available. As we said, normally we design for 60% of the maximum load, but in case there is no space available, then you have to reduce it based on the available space for you. So as we said, as we've seen before, a 1 megawatt system, we have put 600 kilowatt PV cells for it. But in case there's no space for more than 300 kilowatt, then we have to put 300 kilowatt and design accordingly. So these are the rules of thumb that we use in designing our on-grid hybrid and off-grid hybrid solutions. Of course, we provide these designs for free for our customers, so please feel free to contact us anytime on these designs. So this, as I said, one sample design for a PV diesel system with a 1 MVA load. Here we have designed two generators, each 500 kVA, but you can put one extra as a standby in case it's a critical load of that you cannot afford any kind of blackout, in case there's no grid as well. And here you can put two generators of 500 or four generators of 250. Different sizes also available. You can put two 250, one 200, one 300. It's not a big deal. The issue is that the variability of the load defines the variability or the multiplicity of the generator that you can put. The less and the more, it's more controllable for you than putting one generator for one size. And here we can design the PV system for 60%, 70%, of course, with hybrid inverters and depending on the available space. And we prefer also to have the solar installation facing east and west to get more optimized diesel saving because during the sunrise or during the afternoon session. So these are design considerations that we take during installation. For the battery energy storage of different sizing, we can have it based on the load profile, as we said, the night loads, and the space availability for the solar installation. So this is a sample design for 1 MVA load. And the commercial part, uh, we normally provide 25 years of performance warranty, sometimes 30 years. Inverters goes between 5 to 10 years. The project schedules can be 6 weeks, 10 weeks, depending on the size. And also we offer on uh, agreements over 25 years for the system that we can install. Here we come to the third topic, which is the lease and owning of the system. Of course, not every system is better to own it or lease it. So there's always pros and cons, and it depends on the end user requirement or the situation of the projects. So to start with the owning of the solar hybrid system, the positive points that we can use or we can argue for the owning of the solar hybrid system is the long-term cost saving. Owning it might not save you on the shorter term, but it will save you on the longer term, especially after the year 6 up to year 25. The second positive point is that it becomes your own asset ownership. So it appreciates your balance sheet, it adds up to your balance sheet, and gives you a asset appreciation. Also, it gives you an energy independence and control. It's your own consumption of energy, so you will not be paying any kind of penalties or charges for not using the energy like it takes place in the lease agreement. Also, it can be part of your branding or imaging that you own a sustainable and a solar solution, and it can give you a brand impact. On the long term, it has a good ROI, and it depends, of course, if you have a battery system added or you have just a PV diesel system. This depends, but it will give you a good ROI on the longer term. However, on the other side, it has a high initial capital expenditure, especially that you are buying the solar system or the generator, and this imposes a high capital expenditure. It has a maintenance responsibility. You need to take care or train your team to handle it. Also, you need to have the space and the structural requirement means if you own it for 25 years, you need to have the space available for it to install it. In case you have it imposes technical risk and depreciation because with time the technology could downgrade and then you have to update your system regularly. So this could be imposed on you. Also, there will be or there could be a regulatory and compliance challenges in case these regulations of the utilities change over time and forces you to upgrade or change your systems. So these are the pros and the cons of ownership. I will discuss on the last slides what criteria or what is the roadmap to decide how to choose between each. So for the leased hybrid solar system, also it has its pluses and minuses. For the uh, advantages, of course, it definitely has a lower initial investment and it will give you an immediate energy saving costs. So you can feel it directly. Whether once you lease the system, you will have immediate saving on your bills. You will not have any kind of maintenance responsibility. This will be the responsibility of the lessee or the third party, and you will have flexibility and upgradability because since you are not owning the system, you can after this once you have the lease contract finished, you can have a new system fixed up without having any liability on that. So these are the pros for the lease system. On the other hand, some lease agreements will impose long payment terms commitments, and it will be very hard to break these commitments. Definitely you are not having any asset ownership, so it will be an expense on your balance sheet. It will have limited control and dependence on the leasing party because most of the lease agreements will put a minimum consumption. So, in case you are below this minimum consumption, you still have to pay for the difference. And there could be a potential penalties and contractual restriction in case you need to sell your building or move out to another building. Then the lease could stand up in the face of that or have some difficulties in shifting. And on the last part, the financial benefit, it doesn't have a major saving like the ownership of the system give you on the long term. So these are the pros and cons of each of the leased or the owned solar systems. So to take one example, which we have executed, a simulation of costs over a 500 kilowatt load, where we have installed a 300 kilowatt PV system with a 500 kilowatt diesel generators, and we did a comparison between in case there was no hybrid system and in the case of there is of the existence of the hybrid system. So if you see over 3 years, the red line is the total site energy consumption by kilowatt hour, the top line. And with the hybrid solution, the PV generator, the generator is consuming the orange line. So you can see the major difference between the consumption of the generator without the PV generator set and or with the generator alone. And that is due to the green line energy, solar energy production. But however, if you see that the green line, which is the solar energy produced, is not fully utilized because, as we said, during the day, should be a minimum 30% utilization for the generator to keep the spinning curve. So the actual saving is the blue area. The blue area constitutes the utilized solar energy saving during the generator operation. So this blue area is the diesel saving during 3 years of a 500 kilowatt uh, project site. And this, I will show in the next slide how much is saving for us. It's saving around 15 to 20% of diesel over the 3 years. For a project of this size, that could mean a 1 million dirham of saving of diesel fuel over 3 years site operation. And here we can see a monthly bill between the red line, which is the purely diesel operating site, and the green line, which is a PV hybrid, PV diesel hybrid site. So you can see that the difference between the yellow and the red, and this constitutes in the green area down that shows the saving of the system. So this gives, and this we are still speaking about a PV diesel system, which is reliable, operational, optimizing, and renewable. So here, this is a simple, let's say, 3 years. Of course, if we can, depending on the site, of some sites could be working in the night. It has to have a battery, but this is a site configuration of around 10 to 14 hours of operation per day for a 500 kilowatt total load. Uh, to compare it as lease or ownership, so here I'm showing a graph where the red line is the energy cost without any hybrid solution, while the green line is the monthly leased hybrid system. So if you lease a hybrid system and give it for the same site, you will have the green line consumption of diesel. And that's an obvious saving between the red line and the green line. And that's for leasing. And the difference between the leasing and the ownership is that the leasing will charge you a minimum charge per month in case you don't consume the full load or the minimum load that they put it for you. So in case you own it, you can save even more. And that will show here in the blue line. So the blue line here shows the saving that an owned system can give you, considering that there's a high initial cost, definitely. So you have an initial higher cost where you will have this blue line moving on lower than the green line, which is a leased option, which is lower than the red option, which uses a normal diesel genset uh, supply. So there's definitely an obvious saving between a hybrid system owned or leased compared to a pure diesel system. So this brings us to the let's say roadmap of how to decide whether to go for owned or leased system. So first question we ask is the capital availability. Is there capital enough to own the system or there is not? So if there is no enough capital, then we go for the second criteria, which is the space requirement. Is there a space requirement for the system? and this space is definitely we mean it for the PV cells. So whatever is available space for that, we design the PV accordingly. So the first thing is, if there's no capital, we go for the space, because on these lines we will decide finally by with the end user whether to go fully for an ownership or fully for lease. Then we go for the operational need. Does this system require energy independence? We need to be completely independent from the grid, or you want to have it coupled with the grid, or you want to be completely, let's say, having a complete backup system with a full scale generator and or with a backup generator and full scale battery energy storage or not. In addition to that, we ask the end user whether you have the internal technical expertise. So it's very important before deciding whether to own or lease that the end user knows if he has the internal and technical expertise to decide over that. In case you don't have, you need to outsource it, and then it imposes another cost for you. So this is an important point to decide whether to go for ownership or lease. And finally, the duration of the use. We always recommend that in case you are having this system for a long term, we recommend that you go for ownership. However, in case you want it for a short term, we recommend you go for lease. Long and short, we mean by less than 5 years or 6 years, compared to long term, which is 20, 25 years, to make sense. So these 4 or 5 requirements are very important by the end user to define it, so he's able to decide whether to go for a lease or for ownership of the system. So we check the capital availability, what are the space requirement, the operational needs, the technical expertise, and the duration of use. These 5 criteria, based on that, we can make a scoreboard, let's say, and then define the pros and the cons, and then recommend the final decision whether to go for owned or lease system. Ending this session, I would like to show you some future outlooks. Now, of course, you see that the market is trending towards more sustainable solution, but there is one key factor that could be a game changer, which is the battery cost. So we are projecting in the next 10 years that the battery cost could go below $100 per kilowatt hour, and this could be a game changer for the solar PV hybrid solutions to add battery storage on it, because till now the battery storage are above $200 per kilowatt hour, and this is imposing a major cost. We also look that the technology and the innovation can enhance more. We would have more smart grids coming in, especially that in Dubai, DEWA has launched a smart grid strategy, which is going till 2035, that focuses on smart metering and distributed energy management. And this incorporates mainly the PV and the solar solutions into it. So we see that the market trend, the technology, and the innovations are very positive signs, having very positive signs towards implementing more PV hybrid solutions and attending and providing sustainable solutions for the upcoming years. So thank you for joining us today. I'll be happy to answer any questions if you have before we close the session. We have reached already 1 hour, so I hope that this has been very useful to you, and I'll be ready to take any questions at any time. Okay, then. So thank you for attending this session, and we will catch up in future sessions. Thank you all.